Hi everyone. Sorry I'm not at work today. My daughter's sick, so I'm going to be at home taking care of her. I just wanted to give you guys the weekly rundown of what you guys are going to be doing over the next few days. So first I just want to recap what we've been doing in the previous units. So if you guys think back to Unit 5A, we talked about slope. We talked about how to use slope formula to find steepness of a line. We also used rise over run when given a picture to find the steepness of a line. Then we went to Unit 5B. This is what you guys were just tested on. We talked about how there's different forms to write the equation of a line. You have slope-intercept form, point slope form, standard form. And then we also talked about how do you graph lines. There's 4 different ways of graphing a line. That's all on the whiteboard, so you guys can take a look at that. So we are on the last unit of this this whole chapter. So we're on Unit 5C, which is graphing linear inequalities. So this is something you guys have done before, but we're just going to review it today and also tomorrow. So this is what we're doing for this week. So today, Tuesday the 12th, we're going to do section 6.5 in the textbook, which is graphing inequalities. So if you do have questions, feel free to just kind of open up your textbook, read maybe even the intro, or just look over one of the examples in the textbook and you'll probably get your questions answered. Tomorrow, Wednesday the 13th, we're doing a quick review, and then I am going to quiz you guys on what we're doing today on graphing inequalities. So you're only being quizzed on what we're doing today. Thursday the 14th, we are going to review all of Unit 5. So all of this up here is what we are going to go over, because you guys are going to have a test on all of Unit 5 this Friday. Okay, so in a few days. So over the next few days, start looking through your notes, start looking over some old homework. If you need to, look at Chapter 6 in your textbook, just to kind of get an idea of everything that's going to be on the test. Okay, so I am going to walk you guys through today's notes. I'm going to be doing this one-handed, so bear with me because I'm using my other hand to record. Okay, so let's start by naming the notes. Unit 5C. Graphing linear inequalities. Okay, so before we get into graphing linear inequalities, let's review what you guys were just tested on, the different forms that you might see the equation of a line written in. So there is slope-intercept form. This is the form we like to use. Y equals mx plus b. And the reason why we like this form is because m, the number in front of x, is the slope of the line. And that last number b is the y-intercept of the line, meaning where the line passes through the y-axis. Okay, so you have slope-intercept form. We have point slope form. This one is y minus y1 equals m times x minus x1. This one isn't too bad of a form to use if you know how to use it. Again, m, the number in front of the group of x's, that is your slope of the line. And then this x1 number and this y1 number, those are numbers to a point that is on the line. Okay, and then the last one is your standard form. We don't really like this one too much because it doesn't tell us anything. It is just ax plus by equals c. So whenever something's written in standard form, we usually want to rewrite it so that it's in slope-intercept form. We solve for y. This way you automatically know what the slope is, what the y-intercept is. So we're going to see all of these forms here today, maybe not even in our notes, but on the homework today, but they should be familiar to you. So let's talk about inequalities for a second. What is an inequality? Well, that's when you're using the less than symbol or the greater than symbol. So all of our problems today are not going to have equal signs in them, but they're going to have an inequality sign in its place. So let's talk about what we remember about the inequality signs. If you guys just have a regular less than, greater than, and if we were to graph an inequality on the number line with one of these symbols, do you remember what kind of circle we would draw? Would it be an open circle or would it be a closed circle? These would be an open circle. Well, today we're going to be graphing inequalities on a coordinate plane. So when we draw our lines, they're either going to be dashed lines or solid lines. So if you have just a regular less than or greater than symbol, this is going to be a dashed line. So then over here, I'm just going to write the opposite. Let's say I have less than or equal to or greater than or equal to. We know that on a number line, when we draw our circles, this would be a closed or a solid circle. So today when we graph our lines on a coordinate plane, we're going to either have dashed lines or solid lines. So if this one's the dashed line, just like the circle here, this is going to be a solid line. Okay, so let's actually get into an example. So example 1, we are going to graph the inequality y is less than negative 1/3 x plus 5. I am going to have you guys draw your own graphs. I'm going to draw it with you. We're not going to make them very large graphs. Okay, so let's label our x-axis, our y-axis, and I'm just going to do 6 spaces on each of the axes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so get your number line drawn. Once you have that, we're going to go back to the inequality that I give you. We're going to look up here at the 3 forms, or if you need to, look over at the whiteboard. Is it in slope-intercept form, point-slope form, standard form? So it is in slope-intercept form. So we don't need to rearrange anything. We can automatically just start jotting down our information. So we can now write down what the slope of this line is going to be. So the slope is going to be negative 1/3. Feel free to put the negative up with the 1. So if you think about the movement of our slope, if I put the negative with the 1, we're going to go down 1, and then the 3 is positive, so we're going to go to the right 3. And we also can label the y-intercept, where the graph is going to pass through the y-axis. We know it's going to be over here at 5. I'm just going to write it down as an ordered pair, just because that's what you guys have been doing lately on your quizzes and tests, so I just want to get in the habit of that. Okay, so let's go ahead and start plotting these points to get the outline of our line. So we're going to start at 0, 5, 2, 3, 4, 5, put a point there, go down 1, to the right 3, 1, 2, 3, down 1, to the right 3, 1, 2, 3. Okay, or you can go up 1, to the left 3, 1, 2, 3. Now, before you connect your points to make your line, we have to ask ourselves, okay, is it going to be a dashed line or is it going to be a solid line? So you got to go back to the inequality. It is a regular less than sign, so we are going to make a dashed line. So just put little breaks in between the line when you're drawing it. Okay, you're almost done. There's just one more thing you now need to do. So I'm going to write down that when we have a dashed line, let me jot this down here. This is telling us something about our solutions or our answers, because we're just trying to figure out what coordinate points would, if you plugged them into this inequality, would make this a true inequality. So when you have a dashed line, that means all of these points that are on this line, for example, 0, 5, or this one is what, negative 1, 2, 3, 6, okay? All of those points are not solutions to this inequality. So I'm just going to write down that these are our solutions are not on this line. So if I were to basically pick, well, let's say 0, 5, and plug it back into this inequality and then simplify this inequality, I would get a false inequality. I would get a false statement. So we need to figure out what coordinate points would actually work for this inequality if you were to plug it back in. So how you figure it out is we are going to pick a point not on the line, so I can pick any coordinate point that is not on this line. A lot of times we pick 0, 0, just because it's easy to work with zeros. Okay. And I'm going to plug these numbers in for the x and the y into this inequality, and we're just going to see what kind of statement we get when we simplify it. So if I plug 0, 0 into this and simplify, I am going to get 0 is less than negative 1/3 times 0 plus 5. Okay, when I simplify this, 0 is less than negative 1/3 times 0, that's just 0, so you don't have to write it. 5. Is 0 less than 5? Yes, this is a true statement. So if it's a true statement, that means 0, 0 is a solution, and all of the points around 0, 0 are also going to be solutions. So we are going to shade part of the graph that includes 0, 0. So I'm not going to shade above this line. I'm actually going to shade below this line. You guys may remember doing this in your last algebra class. Okay, so my solutions to this line are in part of quadrant 1, because up here you can see those are not going to be solutions. It's also in part of quadrant 2, but up here these are not part of the my solutions. All of the solutions in quadrant 3 will work, and everything in quadrant 4 will also work. Okay, so this entire graph is what I'm looking for. I've got my line. I figured out whether it's dashed or solid, and then I also had to figure out which side to shade to find my solutions. You're either going to shade below it or you're either going to shade above it. Okay, let's do another example. Okay, so for example 2, we are going to graph the inequality negative x plus 2y is greater than or equal to 6. Let's draw our coordinate plane. I'm just going to do the same thing I did before. I'm just going to make 6 dashes. let's go back to our inequality here. Okay, so notice how I have a negative in front of the x, but there's no number there. I'm just going to go ahead and fill in a -1 there, just so I can remind myself there's actually a -1 in front of my x. Now, this is not written in slope-intercept form. What form is this written in? This is standard form. So we don't like standard form. We want to get it into slope-intercept form. We got to solve for y. So how do we do that? We got to move everything away from y. So we are going to add the 1x to both sides. So we get 2y greater than or equal to 6 plus 1x. Now we're going to divide everything by 2 and then simplify. We get y is greater than or equal to 3 plus 1 over 2x. Technically, these should be switched around to put it into slope-intercept form. So we're going to have y is greater than or equal to 1/2 x plus 3. Okay, so this is looking good. So now we can just write down what the slope of this line is. It's going to be 1 over 2. And if we think about our movement, that means we're going to go up 1, to the right 2. And now we also know the y-intercept of this line. It's going to be over at 3. I'm going to write it as an ordered pair, 0, 3. So let's go ahead and graph that. So we're going to start with our ordered pair at 0, 3. And then my movement is up 1 to the right 2. Up 1 to the right 2. 1 to the right 2. Okay, now we're going to go down 1 to the left 2. Now before you connect your points to make your line, you have to ask yourself, is it a solid or a dashed line? So you can either go back to the original inequality or just to the one you finished off with. What do you guys think, solid or dashed? And this is going to be solid, because it has that equals to underneath it. Okay, so we got that it's a solid line. Now we just need to figure out that shading part. So do you remember how to figure out which side to shade? We're either going to go above the line or below the line. So you want to pick a number that is, or pick a point that is not on the line. Most times you can pick 0, 0. Okay, so if I pick 0, 0, those are my x's and y's that I can plug into either the original inequality. I think it'd just be easier to plug into this one. So I'm going to plug it into this here, and it'll now say 0 is greater than or equal to 1/2 times 0 plus 3. We're going to simplify this. 0 is greater than or equal to 1/2 times 0 is just 0, and then you get 3. So is 0 greater than or equal to 3? No, that is a false statement. So if it's a false statement, I'm going to shade the opposite side. I'm not going to shade the side that 0, 0 is on, because this is not a solution because it gave me a false statement. So that means all these other points here will end up not being a solution either. I'm going to shade the top of the line. So there's my entire answer. Okay, we're just going to do one more example, and then that'll be it for the notes. So for example 3, we're now going to graph the inequality 5x minus 2y is greater than 3x plus 4. Okay, let's go ahead and draw the coordinate plane. Okay, so if I go back to my inequality here, notice how this is not in standard form, it's not in point slope form, it's not in y-intercept form. It's really just, it's not in any form. So we're just going to have to solve for y. We're going to go ahead and get it into slope-intercept form. Think of this as an equal sign. If I just kind of split my two sides here, I've got x's on both sides. I'm going to have to bring them together. But ultimately, my goal is to get y by itself. So I'm going to bring the 5x over. How do we bring the 5x over? Well, we're going to subtract it. And I can only subtract it with the 3x because those are like terms. So we have negative 2y is greater than negative 2x plus 4. Now we're just going to divide everything by negative 2. Always watch your negatives. Y is, now since I divided by negative 2, am I going to keep the sign the same or am I going to flip it? We're going to flip it. Negative 2 over negative 2 is positive 1x, and then positive 4 divided by negative 2 is negative 2. Okay, so this is now in slope-intercept form. We can jot down the slope, which is going to be 1, but we can make that into a fraction by putting it over 1. So that means our movement is going to be up 1 to the right 1. And then our y-intercept is going to be negative 2, but I'm going to write it as an ordered pair, 0, negative 2. Okay, so let's go ahead and start graphing that. Go ahead and put a point at 0, negative 2, and then go up 1 to the right 1, up 1 to the right 1. Or down 1 to the left 1. Mine's not perfect, but that's okay. All right, so now you got to ask yourself, solid or dashed line? So you can either go back to the original inequality or where you left off. It's just a regular less than, so that means it is a dashed line. And now we just got to figure out the shading. So how do we figure out the shading? Pick any point not on the line. I'm going to pick 0, 0. I'm going to plug those in for my x and y. I'm going to plug it into my inequality that I left off at. So this will now say 0 is less than 1 times 0 minus 2. So this is 1 is less than, that just cancels out, negative 2. So is 0 less than negative 2? No, this is a false statement. So am I going to shade the side with 0, 0 if it's a false statement? Or am I going to shade the opposite side? If it's false, you shade the opposite side. So we're going to end up shading below the line. Okay, that is it for our notes today. You guys are going to have a riddle worksheet. It is going to be front and back though, and that will be your homework. And then check with the sub, or if you're in my fourth block, check with Mr. Allen to see if there's going to be any other homework. And then once you guys are done, you're going to upload it to Google Classroom. Okay guys, have a great day. Thanks for listening. Bye-bye.